Measure of dispersion for ungrouped data. KSSM Mathematics Form 4. Effect on data changes on dispersion. Example 13. Page 228 to 233. What is the effect of data changes on dispersion? The data changes include the following cases. A. Each data is added or subtracted by the constant uniformly. B. Each data is multiplied or divided by the constant uniformly. C. The existence of outliers or extreme values in the set of data. D. Certain values are removed from the set of data or added into the set of data. What are the effects on the measures of dispersion where each data is changed by adding or subtracting a constant? Consider this case. Initially, have a set of data 5, 8, 3, 4, and 1. If each value of the set of data is added by 5, then the data above will be changed to 10, 13, 8, 9, and 6. What will happen to the measure of dispersion such as range, interquartile range, variance, and standard deviation from the new set of data? Firstly, sort the data from small to big. Then the range is equal to the maximum value minus the minimum value. 8 minus 1 equal to 7. The quadratic range is equal to
好，请你们把 interquartile range 的答案写出来，谢谢。什么减什么 ？What value minus what value？ How can 4 minus 8? Interquartile range always positive. Okay, let's see the answer.
the third quartile minus the first quartile. Before that, you need to find the median. Median is the middle of the whole data, that is 4. After that, you need to find the third quartile. 4 is the median. After median, there are 2 data. Third quartile is in the middle of these 2 data, that is 5 plus 8 per 2 equal to 6.5. Then we need to find the first quartile. Before the median, there are 2 data. The first quartile is in the middle of these 2 data, that is 3 plus 1 per 2 equal to 2. So interquartile range equal to 6.5 minus 2 equal to 4.5.
所以明白吗？是 4.5， 也不是8减4。那找 interquartile range， 第一个先找出 median， 所以从最小的排到最大间 ，median 呢就是说中间那一个 ，OK， 所以中间那个明显是4。不过呢，我们再找 third quartile， 因为 interquartile range 等于 third quartile 减 first quartile。third quartile 呢，我们先看 median，median 后面有2个，这2个里面的中间 ，OK， 我 median 后面有3个，就3个里面的中间。这个是 median 的后面只有2个，所以2个的中间呢，就是5和8的 average， 所以拿5加8除2， 8加5是13除2得到 6.5。OK， 过后我们再减 first quartile。first quartile 也是一样，我们先看 median 的前面有2个 data， 所以就找这2个 data 的中间，2个 data 的中间在这里。如果 median 前面有3个 data 呢，就找3个 data 的中间 ，OK， 2个 data 的中间刚好是这个2个数字的中间嘛，所以拿3加1除2，所以3加1 4， 4除2得到2，所以拿一项减得到 4.5。Understand？ 好，我们接下去。
In order to find variance, we need to find mean. Mean is equal to the average of the data, equal to 4.2. Variance is equal to, we square all these numbers and add all of them, 10 per 5, minus the mean square, equal to 5.36. Standard deviation is equal to the square root of variance, that is square root of 5.36 equal to 2.3152. Then each value of the set of data is added by 5. Become 10, 13, 8, 9 and 6. Then we sort this from small to big. Then we find the range is equal to 13 minus 6 equal to 7. The quota range is equal to,
所以这个又等于什么减什么 ？In the quota range equals to what value minus what value? Please answer.
(11.5 minus 7 equal to 4.5.
所以也是一样的，因为它只有5个数字，所以third quota一定是这2个数字的中间，first quota也是这2个字的中间。10加13除2得到 11.5，6加8除2得到7，这2个相减得到 4.5。
Mean is equal to the average of the data, that is 9.2. Variance is equal to 5.36, and standard deviation equal to square root of 5.36 equal to 2.3152. So range, interquartile range, variance and standard deviation for these two sets of data are same, only mean is different. So there are no changes to the measure of dispersion when each value of a set of data is added or subtracted by a constant. Mean is not a measure of dispersion as it cannot show the dispersion of data.
OK， 所以这个要背起来呀，这个要记得，因为接下来的 exercise 就是有需要根据这些东西来回答的。所以不管那 data， 只要是每个 data add 还是 subtract 的话呢，它的 measure of dispersion 是不会改变的。然后 mean 本身不是 measure of dispersion， 因为 dispersion 是指分散 ，measure of dispersion 就是它能够测量它的分散度。OK，mean cannot measure the dispersion。OK， 所以它不就是因为它不能 show dispersion of data， 所以 mean is not。Although the value is different. Okay, the value is different, but mean is not measure of dispersion. The measure of dispersion is range, interquartile range, variance or standard deviation. Okay, mean is not the measure of dispersion.
A measure of dispersion as it cannot show the dispersion of data. Is subtracted by a constant k equal to is added by a constant negative k.
所以当我们讲说，因为这里是讲说added or subtracted 嘛，对不对？然后我给的 example 那个只是 added 而已，没有 subtracted 的。其实比如讲它 subtracted by k， 反过来讲它就是 added by a constant negative k。OK， 所以 subtracted 的意思也是 added 的意思，只是要变成 negative k 而已。所以不管是加还是减呢，得到的答案都是不会改变的 measure of dispersion。所以这个要记得。所以变成 example 我只给一个吧，只给加吧。OK， 我们 continue。
What are the effects on the measure of dispersion when each value of the self-data is multiplied by a constant? Consider this case. Initially, have a self-data 58341. If each value of the self-data is multiplied by 2, then the data above will be 10, 16, 682. What will happen to the measure of dispersion such as range, interquartile range, variance, and standard deviation for the new set of data? For this set of data, the range, the quartile range, mean, variance, and standard deviation are same as previous. Then each value of self-data is multiplied by 2. Come 10, 16, 6, 8, and 2. Then sort it from small to big. Then sort the data from small to big. And range equal to maximum value minus the minimum value, 16 minus 2 equal to 14. Interquartile range equal to the third quartile minus first quartile. Like previous, the third quartile is in the middle of these two data. 10 plus 16 per 2 equal to 13. And the first quartile is in the middle of these two data. 6 plus 2 per 2 equal to 4. So interquartile range equal to 13 minus 4 equal to 9. Mean is equal to the average of the data, equal to 8.4. And variance is equal to square all of the data and add all of them per 5 minus mean square equal to 21.44. Standard deviation equal to the square root of variance, mean square root of 21.44 equal to 4.6303. We found that the range 7 multiplied by 2 equals 14. Then in the quartile range, 4.5 multiplied by 2 equals 9. And then the mean 4.2 multiplied by 2 equals 8.4. And then the variance 5.36 multiplied by 2 squared equals 21.44. And finally, the standard deviation 2.3152 multiplied by 2 equals 4.6303. In conclusion, when each value of the self-data is multiplied by the constant k, then new range equals k multiplied by original range. New interquartile range equals k multiplied by original interquartile range. New standard deviation equals k multiplied by original standard deviation. And the new variance equals k squared multiplied by original variance.
OK， 所以这个就是 multiply 就是乘。同样的，如果是 divided 的话呢，也就是乘一百 k 的意思，所以是一样的东西。OK，is divided by a constant k 的话呢，一百 k 乘什么，然后就变成一百 k square， 所以是一样的。OK， 这个也要记得啊。Any questions?所以也就是指说它每一个 value multiplied 或 divided by the same constant, okay, must be each value, okay. If one of the value multiplied by the constant, then this formula will not work. This formula only works when each value is multiplied by a constant, okay, a constant, any values, positive, negative also can. Okay, let's continue.
What are the effects on the measure of dispersion when each value of subdata is divided by a constant?
这是我特地做出来的，基本上课本里面没有的，所以你们自己看，基本上是一样的啦。
Consider this case. Initially, have the subdata 58341. If each value of the subdata is divided by 2, then the data above will be 2.5, 4, 1.52, and 0.5. What will happen to the measure of dispersion such as range, interquartile range, variance, and standard deviation for the new set of data? So for this subdata, the answer is just like previous. So each value of subdata is divided by 2. Come 2.5, 4, 1.52, and 0.5. And then we sort them from small to big. So the range equal to 4 minus 0.5 equal to 3.5. Interquartile range is equal to the third quartile minus first quartile. The third quartile is in the middle of these two data. 2.5 plus 4 per 2 equal to 3.25 minus the first quartile. The first quartile is in the middle of these two data. 0.5 plus 1.5 per 2 equal to 1. So interquartile range equal to 2.25. Means equal to the average of the data equal to 2.1. Variance equal to square of all the data, add of them per 5 minus mean square equal to 1.34. Standard deviation equal to square root of 1.34 equals 1.1576. Then we find that the range 7 divided by 2 equals 3.5. Then interquartile range 4.5 divided by 2 equals 2.25. Then the mean 4.2 divided by 2 equals 2.1. Hence the variance 5.36 divided by 2 square equals 1.34. And standard deviation 2.3152 divided by 2 equals 1.1576. So when each value of subdata is divided by the constant k, new range equal to original range per k, new interquartile range equals original interquartile range per k, new standard deviation equals original standard deviation per k, and lastly the new variance equals original variance per k squared. Is divided by the constant k equals is multiplied by the constant 1 per k.
OK， 所以这个你即使不要记也不用紧了。刚刚讲 divided 其实就是乘的意思。OK， multiplied by a constant 1 per k， 所以只要记得乘的就可以了。就是 original range multiplied by 1 per k， 然后这个也是 multiplied by 1 per k， multiplied by 1 per k， this one multiplied by 1 per k square. OK。
What are the effects on the measure of dispersion when an outlier is added or removed from the set of data? A. Range. The range will change dramatically when an outlier is added or removed from the set of data. B. Interquartile range. The interquartile range is less affected when an outlier is added or removed from the set of data. C. Variance and standard deviation. The variance and standard deviation will increase significantly when an outlier is added into the set of data. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. If the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa. C will be proved in example 13. is a set of data, and the values here is equal to this. Okay, median is 39.5 and so on. 7.5 equals 39.5 minus 32, and 5.5 equals 39.5 minus 34. If we add an outlier, let's say 100, the range changes from 16 to 68. So the range will change dramatically when outlier is added or removed from the set of data. And then we see the variance and standard deviation. The variance and standard deviation increase significantly when outlier is added into the set of data. It increases a lot. The original mean is 39.5. If we add a new data where the difference between the new data and mean is small, let's say 39, so the variance becomes smaller and standard deviation also becomes smaller. If we remove a data where the difference between the removed data and the mean is small, for example, if we remove 39, the variance and standard deviation increase. It means if the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa.
OK， 所以这个等一下教完过后呢，我会解释这个我是怎么做的，这是 Excel 嘛，它的 formula 是怎么组成的，这也花了我一些时间去想出来的。因为原本 Excel 呢，它能直接找出 range， 然后呢，至于 median 可以直接找出来，然后它可以找出来的 first quartile、third quartile 是不一样的。我们呢必须用课本的方法。之前Excel 给我们的 first quartile、third quartile 是用它的 formula 的，也是我之前给你们那个 formula 的。可是课本教的方法是不一样的，所以变成我要自己重新想过要怎么算出来。OK， 这个等一下有时间的话我会解释。至于其他的，基本上Excel 里面已经有这些方式了，只是你要找 median 的话呢，你要把这个 data 先 sort 起来，没有 sort 的话是不能用的。OK， 当然这个已经是 sort 边边了啦。不过其实事实上我把这些东西调转的话呢，这些答案也不会改变。OK， 那么里面的 formula 我已经把它 sort 边边了的。所以等一下上完课过后我会解释一下，如果你们要听的话可以继续留下来，我会解释这个我是怎么做出来的。至于为什么这样多 data 呢，其实是为了让你们知道，当我这些 data 我比如讲每一个加1的话，越加越多的话，它的变化是什么 ？OK， 那有时间还做给你们看。这个是已经录好的 ，OK， 好，我们接下去。
How do you determine the effect of data changes on dispersion based on graphical representation? The effect of data changes can be graphically displayed by using dot plot, standard leaf plot, or box plot. A. The data is changed uniformly so by adding or subtracting a constant. Let's see this dot plot. Score in sign quiz. When each value of the set of data is added by 2, the dot plot becomes like this. In the diagram, when each value of a set of data is added by 2, it is found that the whole dot plot is shifted to the right by 2 units, where the dispersion remains unchanged. It shifts 2 units. The original score range equals 15th minus 8 equals 7th, and the new score range equals 17th minus 10th equals 7th. So the range of both sets of data is the same. When each value of the set of data is added by a constant, the measure of dispersion remains unchanged. B. The data is changed uniformly by multiplying or dividing by a constant. Let's say this dot plot score a mathematics quiz. When each value of the self-data is multiplied by 2, the dot plot becomes like this. In the diagram, when each value of a set of data is multiplied by 2, it is found that the dispersion of the whole dot plot becomes twice as wide. Original score range equals 5 minus 1 equals 4, and the new score range equals 10 minus 2 equals 8. The range of the new set of data is 2 times the range of the original set of data. When each value of a set of data is multiplied by a constant k, the new range equals k multiplied by original range. In general, when each value of a set of data is multiplied by a constant k, the measures of dispersion will change. C. The value added or removed is an outlier. For example, this dot plot score a mathematics quiz. When an outlier 9 is added, the dot plot becomes like this. In the diagram, when an outlier is added to a set of data, it is found that the dispersion of the whole dot plot becomes wider. This is wider than this. The original range equals to 5 minus 1 equals 4. New score range equals 9 minus 1 equals 8. The range of the new set of data becomes larger compared to the range of the original set of data when an outlier is added. The measures of dispersion of the new set of data becomes larger compared to the measure of dispersion of the original set of data when an outlier is added. Example 13. Given a set of data 4, 6, 7, 7, 9, 11, 12, calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when A. 4 is removed, B. 7 is added, and C. 18 is added. The mean of the set of data is average of the data equals 8.5. Standard deviation of the data equal to square root of variance. So the variance equals square all the data, add all of them, a total number of data minus mean square. Square root of variance equal to standard deviation equals 2.784. A. 4 is removed, and the mean becomes 9.143. Standard deviation becomes 2.356. When the value that has a greater difference from mean is removed, the new standard deviation will be smaller. The value that has a greater difference from mean is removed. Standard deviation will be smaller. The value that is removed is 4. The mean is 8.5. The difference is 4.5. So 4.5 means a greater difference. It says the new standard deviation will be smaller. Let's see. Original standard deviation is 2.784. The new standard deviation is 2.356. It clearly becomes smaller. B. 7 is added. So the means become 8.333. And the standard deviation becomes 2.668. When the value that is close to the mean is added, the new standard deviation will be smaller. This is the value that is close to the mean. The value that is added is 7. The mean is 8.5. And so 8.5 minus 70 equal to 1.5. So 1.5 means close to the mean. So the standard deviation will be smaller. Original standard deviation 2.784. New standard deviation 2.668. It really becomes smaller. See, 18 is added, so the mean becomes 9.556, and standard deviation becomes 3.974. When the value has a greater difference from mean is added, the new standard deviation will be larger. The value has a greater difference. The value added is 18. The mean is 8.5. 18 minus 8.5 equal to 9.5. 9.5 means a greater difference from mean, so the new standard deviation will be larger. So the original standard deviation is 2.784 and the new standard deviation is 3.974, so the difference is greater.
Any questions? If no questions, let's see the questions. Okay, self-practice 8.2D, number 1. Okay, read it yourself. It applies all the things that I have taught just now. So all 6 questions applied all the formula. For the first one, it says each value of the self delta is added by 4. So according to the formula, we know that okay, there are no change the measure of dispersion, but each value of set data is added or subtracted by a constant. And so, for the first question, you don't need to calculate anything. They still have the same answer, 6 and 3.2. Okay? And also for number 2. For number 2, we give the interquartile range and standard deviation so 3 and 1.8, and then we need to calculate the new interquartile range and new variance. Okay, we give standard deviation, we need to find the new invariance if the set of the data multiplied by 3. So you use the another formula. So use this formula to find. Okay. And then number 3, we say explain the change of standard deviation if 70 is added to the set of data. What will happen? And then number 4, this is the original data, and then this is the new data, and then we find that this one multiplied by 2 get this one, and then this one divided by 2 we get this one. Okay. And then number 5, combine the two conditions. The first condition added by 2, after that multiplied by 4. We should know that when added or subtract, we make no change, so we just carry the second condition only, multiplied by 4, then we multiply to 2, 25 by 4 and 27 by 4. And then number 6, we say that each value is divided by 3, so the standard deviation and range also divided by 3. Subtracted by 2, we make no change, so we don't care the second condition. So this is the question for 1 to 6. Apply all the formulas that we learned just now. Okay, it's very easy. So this is the homework for you. You can do this and pass up on next Monday. Okay. Now you can leave.